welcome to this video. Today we're going to look at this functional problem. So we need to find all functions that go from the real numbers to the real numbers that satisfy f of xz plus f of xy minus f of x times f of yz is bigger than or equal to 1 for all x, y, and z that are real numbers. So usually with these types of problems, you want to plug in maybe all of them are the same, or all are 0, or some are 0, and see what you get from there. And here, the first thing we're going to do is let all of them be the same. So we'll set them all to be a, and then you can see we get f of a squared and another f of a squared. That's 2f of a squared minus f of a times f of a squared that's bigger than or equal to 1. But now, remember, we can choose a to be anything we want. And it would be very nice here if a squared was equal to a, because then we'd have an equation, and because then we would have an inequality with f of a, with f of a. Then maybe we'll be able to gather information on f of a, where a squared is equal to a. But luckily, a squared is equal to a only when a is equal to 0 or 1. So let's look at them. So if a is equal to 1, for example, we get 2f of 1 minus f of 1 times f of 1 will be f of 1 squared. That's bigger than or equal to 1. Now we'll move everything to one side. So we get f of 1 squared minus 2f of 1 plus 1 is smaller than or equal to 0. But you can see this is actually just f of 1 minus 1 all squared. And because f goes to the real numbers, it is a real number. So f of 1 is a real number, minus 1 is still a real number. And because any real number squared is non-negative, so this has to be bigger than or equal to 0. And if it's smaller than or equal to 0, bigger than or equal to 0, f of 1 minus 1 all squared has to be 0. So f of 1 minus 1, this bit inside has to be 0. So f of 1 has to be 1. And similarly, if we plug in a is equal to 0, we get the same thing. F of 0 is equal to 1. So just f of 1 is replaced with f of 0, and then everything is the same. So now we have these values for the function. Now, because like we saw, y and z are a bit special, because we saw that the values 1 and 0 are a bit special in the way they work here in this equation, let's try to plug in just y and z are equal to, let's say, 1. So if y and z, if y and z are both equal to 1 and x is free, we get f of x plus another f of x. That's 2f of x minus f of x times f of 1. But f of 1 is 1. So just minus f of x minus f of x is bigger than or equal to 1. And so f of x is just bigger than or equal to 1. Alright, now let's plug in y is equal to z, which is equal to 0. This time we get f of 0 plus f of 0, which is 2 times f of 0, but f of 0 is 2. So this is 2 minus f of x times f of 0. F of 0 is 1. So minus f of x is bigger than or equal to 1. And keep in mind, by the way, these are both for all x that are real numbers. Now, f of x smaller than or equal to 1, meaning, and what is the number that is both bigger than or equal to 1 and smaller than or equal to 1? only and only 1. And so what we get is, just from these two, we get that f of x is equal to 1 for all real numbers x, because we set x to free in both of these. And now we got a solution. We just need to check that it works. And of course, 1 plus 1 minus 1 times 1, 2 minus 1. It's 1, bigger than or equal to 1. So f of x is equal to 1 does satisfy our equation, meaning that this is our solution. And finally, that's it. If you want more content like this, please subscribe to my channel. I'll be uploading more interesting problems and things like this in the future. And finally, that's it.